Hey everybody, and welcome back to another installment of Dan's Pro Shop. I'm your man Dan. We got another good one for you today. And man, I tell you, I feel like Steve Harvey every time I say that. Hey, we got another good one for you today. Anyway, if you guys are familiar, I have reviewed a BestArc plasma cutter in the past. Actually, that's this guy right here, this like tealish color thing. Well, they have recently released a line of like small portable suitcase style MIG welders. This is a new thing for them. And since I was so absolutely blown away by that plasma cutter, and in case you haven't caught that video, check it out up here, or I'll link it in the description. Check that out later. Honestly, it's awesome. So my hopes are high for this little guy. Let's dig into this thing and see what it's all about. So guys, like I mentioned, this is the newest offering by BestArc, appropriately named. I don't know. We'll figure out, right? But this is the MIG145. And in case you're new to welding and don't understand what MIG is, it's actually an acronym. It's metal inert gas. That means, well, if you guys are familiar with gases, you know, gaseous state, like the states of matter, inert means non-flammable. So whenever you use a shielding gas with a welder, obviously you don't want it to flame up. The whole point of this is usually you use something called 75-25. That's 75% argon, 75% CO2. That is a shielding gas that removes the atmosphere, like oxygen and nitrogen, from your weld pool and creates a really good environment for that arc to happen. So I know I'm getting a little deep here, but that's what inert gas means. Same thing with TIG. That's an acronym. That means tungsten inert gas. So you are using a tungsten to create your weld. Either way, I'm getting off topic here. This guy, the MIG145, this is a dual voltage wee little suitcase welder. Dual voltage meaning this thing runs on either 120 regular residential wall outlet power or the 240 plug that's in most garages. And let's be honest, if you need to rig something up in your house, you can plug this into like where your stove goes or the dryer in the basement. But either way, you're not limited to that high voltage 240 like you would have in the garage or the shop or whatever, because this guy gives you the ability to run on 120. So yeah, I'll keep on digging in the box here and show you guys this thing whenever I get it out and you can see it. Man, oh man, would you look at this cute little guy? I mean, this thing probably weighs, I don't know, maybe 10 pounds on a good day. Naturally, we don't have wire or anything in it yet, but look at how small and compact this thing is. Just so you guys get an idea, we are 9 inches tall, 13.5 long, and just a skosh under 6 inches wide. So this thing, honestly, I mean, I think my lunchbox is bigger than this thing. It's absolutely awesome. It comes with the whip already attached. Looks decent. I mean, this isn't going to be a showstopper, but for what we're attempting to do with this, I think it's going to be fine. It has a regular gas nozzle here, a diffuser with a regular, looks to be an 030 tip, I believe so. And yeah, the nozzle just presses on there like normal. Got a nice little hanging clip. And then back here, we have our regular 110 plug like I was talking about earlier. And it comes with this fancy little dongle that we can plug this into this. And now we have access to 240 volt power without doing any wiring or changing to the actual machine itself. You simply just plug this in and the machine will recognize that you have a different input voltage. So this is going to be super handy. And in the accessory kit, check this out. Apparently, we can use this as a stick welder also. Absolutely awesome. I wasn't expecting that. I really thought that this thing was just a buzz box. But now we can burn rods with it also, so that gives you that versatility. If you're in a situation for whatever reason you can't use MIG, like let's just say that you only have solid steel wire, which you need a gas for, and you don't have gas, either you can use flux cord or you can burn regular rods. It's nice to have that versatility. Obviously, we have our nice little ground clamp with the quarter turn disconnect, same thing as the stick handle there. And we have a gas hose. Should you choose to put shielding gas onto this machine, it comes supplied with the hose that you need to do that. And fancy little shoulder strap. So you can rig this thing up and carry it around on your shoulder like a tool bag, because it's small enough that honestly you can do that. Comes with a little bag of consumables here. Feed roller for different size wires. A couple different tips. Nice little thing of Teflon tape there just in case. So, since we're over here at the bench, and I have 120 readily available here just on an extension cord, let's just plug into that and see what the display has to say about it. We'll just spark this thing up and see what it does. I'm going to do my best to try not be in your way during this. Go ahead, we'll plug it in. We got juice. There's a regular rocker power switch here on the back, along with the gas inlet and a cooling fan. I'll show you when we get there. We'll go ahead, turn it on. Bunch of clicking and clacking relays inside. Nice full color LCD screen. You guys hear that? The cooling fan's already running. So that keeps the heat sinks and everything in there jiving and happy. On here, we have what seems to be 4 different touch pads and a selector knob for our voltage and amperage. I can only assume that this is going to be for our wire speed also. But you guys can see here on top, maybe you might be too far away. Hold on, let me bring you in so you can see the screen a little better. So in the top left here, it displays that we are connected to 110 volts AC. And on the right side here, this just simply means that the fan is running on the inside of the unit. Over here, we have synergic, I don't know what the heck that means, amps and volts. This is our current voltage, and this is our current amperage. Right now, the select is on MIG. Evidently, we have the capability to do TIG with this also. And MMA. So, I don't know. Metal something arc? I don't know. I'm guessing that's stick welding. But here up top, it says gas or gasless. That means either you're using flux cord or solid wire. So you have the ability to MIG weld without a shielding gas. Then over here, wee little bit in the corner, this is how you select your wire size. So right now we are on 030, just like the tip that came in the gun. So let me do some playing around and see how this thing goes. And let's just light up an arc and see how it works. Silly me, I'm getting excited here. How do you expect to pull the trigger and do something whenever there's nothing coming out of the gun? So you guys can see here on the top, there's latches on either side. They're spring loaded, so whenever you pick it up, they just come off. The whole top flips up. So like if you guys are familiar with MIG machines, usually the side of the machine lifts up or opens up, whatever, and then that's where your spool of wire goes. This one is on top. So you have your regular set of feed rollers, the spindle where the spool will go, and there's a button that allows you to power feed your lead. I'll bring you guys in and show you this and how that whole thing works. So another thing I forgot to mention that comes in the kit, they supply you with 2, probably what seems to be like 1 or 2 pound spools of wire. So if I had to guess, 1 is flux cord and 1 is solid. So yeah, this is solid 030 wire. And this one, yep, flux cord 30. So we'll just go ahead and open this guy up. Now, if you guys have never done this before, there is a thing in the welding industry that we refer to as a bird's nest. And that is something that you want to avoid at all costs. Bird's nest means whenever you're doing this particular task, this spool will come unwound on you and it just takes off like a rocket. And then you just get this bird's nest of wire that you absolutely can't do anything with. So just keep that in mind whenever you're doing this, to don't let this wire go, because it'll become your worst nightmare. Also, pay attention to how this thing unspools. We want this to uncoil towards the direction of the liner here. So we're going to undo this guy. Keep a hand on this. Like I said, we're trying to avoid a bird's nest here. Put the top collar on the stud here. Maybe if I can figure out how it goes on. There you go. And then we have a spring-loaded tension nut. Holds everything in place and gives it a little bit of drag, which is good because that prevents our bird nest issue. So this guy right here is how you adjust the tension on your feed rollers. This post has a turning knob on it with a spring, so that it holds this lever under spring tension. You loosen this up, flip it out of the way, and your feed roller moves. Actually, this is the idler roller. This guy is the feed roller. So this moves out of the way so you can load your wire. Keep a hand on this thing and start feeding it through the liner. You will see it come out of the other side in the feed roller, and I'll move you guys over here so you can see what I'm seeing. So here we have the wire coming off the spool in the correct direction, feeding through this first piece of liner here, and then into the feed rollers. Like I said, this is the drive, this is the idler. Once you get it through here, now we need to feed it into the actual liner of the gun. This can be a little cumbersome, but I promise you it does work. It just takes a little bit of wiggling and conniving. Now, once you have the wire fed through the entire way into the liner here, now we can close our drive rolls and appropriately adjust the tension on this. This determines how hard the machine pushes the wire through the gun. So in the event you have a kink in the liner or something doesn't work, this will start to slip before it attempts to jam all this wire up your gun. Now that this is all set together, like I mentioned, this button right here, this runs the feed roller. So on the other side, there is a best practice for this. I'll show you how that works. So now that we have our feed roller all set up, the next thing we need to do is disassemble the tip of the gun. Because, I mean, you can do it with this assembled. I strongly recommend that you do not, because I have done this before and it has ruined liners. Because the wire coming through here isn't really the straightest, or you got a jagged cut or something, and it'll get up to the tip and kind of like jam, and then you get a bird nest condition. So do yourself a favor and just take the nozzle out of the gun. And most welders, you can either hold the trigger to run your power feed, but if you are connected to a gas, you can also burn through a lot of it unnecessarily. That's cool that we have this little button here. So we want to make sure that this is kind of as straight as possible, minimize the kinks, nice easy curves here, then hit the button. This will feed the wire through, and you guys will see it pop out of the end here once ever it's where it needs to go. Look at there. We're all the way through. Now we can reassemble the torch. Got the wire all the way through the liner here. I run a little bit extra. Cut that off just so you got a nice clean end there. Reinstall the tip. Tighten everything up, and then we'll put the nozzle back on. Nozzle simply just presses right on. Pull the trigger, make sure everything still works. Adjust the tension knob on your feed roller as necessary. Clip it off, and now we should be good to spark an arc with this thing. So guys, after some further investigation here, Like I said, down here, this controls what size wire you're on, because I guess it wants to know that for your amperage range. Over here is how you select your process. Up here is the 2T and 4T. I had that issue trying to figure that out with the plasma cutter, and I figured out this is what controls your arc and your trigger response. So if you're welding something, or in the case of the plasma cutter, if you're cutting something that's like porous, like expanded steel, or that metal with a bunch of little holes in it, you can go over those holes and not lose your arc. So that's what changes between 2T and 4T. I don't know how pertinent that's going to be for a MIG welder since you have such control over the trigger, but either way. And then on the right side, we have gas and gasless. Since we're using flux cord for this test, I don't need gas. You choose gasless. That would control the valve, like the solenoid valve in the back, that would allow gas to go through this. But for the sake of this test, we're going to do solely flux cord because of the simplicity and mobility of this thing. I'm really not going to use this for solid wire welding, and that's kind of not the point here. This is something like you could throw on the back of the quad or in a tractor or something. Run this off a generator, weld something up in a field real quick or down at the barn, whatever you got to do. But I'm probably never, ever going to hook gas to this, so we're going to run flux cord and see how well that works. And another thing that I have found, this knob here, yes, it controls our amperage, but it does not necessarily separately control our wire feed like a traditional MIG gun. Usually you would have a knob for heat and a knob for speed. Evidently, this one is kind of tied together. If you guys can see here, it goes slow, and as I crank up the knob with more amperage, the feed goes up with it. I'm not crazy that that is not a separate thing, because if you guys have ever welded before, being able to fine-tune those two different things is kind of a big deal. So I'm skeptical on whether this is going to work well enough for me to actually like it, but either way, we're going to go for it. Well, guys, excuse the costume change here. It's a new day. I ran into some stuff. I had to stop what I was doing at the time. But either way, we're back, and I think we're in the right spot. So we're just about to strike up an arc with flux cord with this fancy new little thing here. Now, I know I may come off like a broken record here, but this thing is dual voltage. That is a big deal. So depending on the input voltage that you give this thing, be it 120 or 240, that directly affects the output voltage of it. Hopefully you guys can figure that out for yourself. But it does greatly limit your capacity or amperage, if you will. So right now, the way we are set up with flux cord, we are absolutely capped out at 125. That is all she got. That's all it can do. I'm sure that that will increase with 240, but like I mentioned, the whole purpose of this test is the usability on like the grab and go scenario. So we don't have 240, we got 120. I know it can do it, and if you can do it, cool. But for this, we're not going to do that. Another thing that I may have overlooked here, if you are running flux cord, it is super paramount to wire this thing with DC negative, meaning that you put the gun in the negative port and your ground in the positive port. I'll show you what that means so you actually see what I'm talking about. So here we are at the front of the machine. There's 3 ports in the front, and the center one has a whip on it. This is the electrode that connects your MIG gun to the outputs of the machine. And you can see here on the left is positive, on the right here is negative. Now, traditionally, with regular stick welding or solid wire, you would have your gun on positive and your ground clamp here would go into the negative, right? Just like you would think. However, with flux cord, some machines, not all of them, but some of them require this to be wired negative, meaning reverse polarity, DC electrode negative. So the gun needs to be plugged into the negative port, and your grounding clamp would go into the positive. So technically what's happening is the electricity is coming from the ground clamp through the material and back up into your MIG gun. It's exactly opposite of what you would think, but that does make a difference when running flux cord. Keep that in mind if you're doing this. And just in case you need a quick little reminder here, there is a chart up under the lid that describes what kind of material you're doing, what kind of wire you're using, and the appropriate settings for different thicknesses and everything. So you have like a quick reference chart here so you know how to set up your machine appropriately. All right, I promise I'm done talking. But in case you're new to welding, this is important stuff to know. So we are just going to get right down to it. I got us a chunk of 1/4-inch angle iron, and I'm just going to throw it up on a piece of wood here so I don't melt a hole through my table. So, like I mentioned, we have this machine set up at its maximum capacity, the absolute most that it can do with a 120 volt extension cord. We're going to hook up our electrode, or our ground, in DC electrode negative. That makes a difference. So we're just going to spark this thing up and see what she's got. Tell you what, let's just do another one while we're right here. So guys, I don't know how well that showed up on camera, but like I mentioned, not being able to control the heat and the wire speed separately, I'm noticing that. I would really like to keep the incoming wire a lot closer to the puddle than what it is. It seems very variable, like it's kind of jumpy. It's not as in the puddle as I would like it to be. Now, naturally, we are limited by incoming and outgoing voltages here. But that being said, it works. Now, like I mentioned, flux cord is a totally different animal than solid wire. It is nowhere near as clean. I feel not as effective, but it does work. I mean, flux cord is used everywhere all the time, and for good reason. It works. It's just not as nice as solid wire. So let's get in here, deslag this stuff, clean it up a little bit with the wire wheel, and actually see what we got out of it. So guys, like I mentioned, flux cord does create a slag, much like regular stick welding does, because that's what protects the weld pool from the atmosphere. So whenever you're doing flux cord welding, this is a step that you have to take that you wouldn't with regular solid wire. But since we're not using a gas, we don't have a regulator, this is the good option. Now you guys can see here my first pass versus my second pass. I don't know, maybe I just had a dirty nozzle or it was the beginning of the spool or something, but we got a little bit of porosity in here. Porosity meaning holes blown out in your weld. That usually points out that you have a dirty weld pool or an inadequate arc. I feel like this is kind of both. Since the arc isn't as hot as I would like it to be and the wire speed isn't exactly where I want it to be, that doesn't get the arc that you're exactly looking for, but obviously you can see that it does work. Up here, we got a little bit better, and so we don't have near the porosity that we do down here. I would even venture to say that we have no porosity on this second one. But like I said, this is just a junk piece of angle iron. There's still mill slag on here. I didn't grind it or clean it or anything. And, I mean, who knows where this wire comes from? It's not the best stuff in the world, but it came with it, so you can use it right out of the box. Either way, can it weld? Yes, this machine will weld. Would I put a bridge together with it? Absolutely not. But if you need to fix something dumb small on the weekend, this will meld it together. Cool. So does it weld? Yeah, it sure does. I mean, you have your limitations, and I keep on saying this. It will change with the voltage you put in. But I feel like 95% of you out there, if you have this thing, you're going to be using the 120 because you don't have access to the 240. So we are really leaning on that side of this test, because if you have access to 240, chances are you probably have a better machine. You got a garage with 240, you're set up for this kind of stuff. That's really not what this thing is catering towards. This is for the novice that's getting into it, that kind of wants to build a skill set with welding. And this is a good introductory way to do that without breaking the bank. And it will let you get those dumb little projects done that, you know, maybe you just couldn't do before, but now you can tinker with and do. So that being said, here is another dumb little test that we're going to do since we're already here and set up for it. Now, this may be extremely out of the realm of what you're trying to do here, but we have 1/4-inch angle iron and 2-inch square tube. They are both 1/4-inch wall, and we're just going to butt them together and make a V fillet. So I don't know, maybe we'll just do a couple passes over this and just see how this turns out. But this is a very real world scenario that you would run into whenever you need to put two pieces of steel together in a perpendicular configuration like this, and you just need to fill up that corner. So we're going to do that and just see how well it works maxed out on the 120 extension cord, and just lay the flux cord to it and see what we get out. So here goes nothing. We're just going to lay it in there. Man, I got to tell you, that flowed in there a lot better than I expected. Let's clean that up and see what we're left with. So guys, I am genuinely impressed here. Check this out. We got a good solid, probably 5/16 or 3/8 fillet weld with one pass from a 120 volt extension cord, and using just regular old flux cord with no gas. Since we're here, I'm just going to run a couple more over this, do a multi-pass on here, and see how well that turns out. I mean, because the root went so well, I'm guessing that the caps are going to do fine too, but we're going to do this just because. Honestly, at this point, I'm just most curious about the duty cycle of that little guy. Can this thing actually keep up with the rate of welding that we're doing? Now, if you're doing a weld that involves multiple passes like we're about to do here, and you are using flux cord, you have to remove the slag and clean the previous pass before you put another. You cannot put new weld on top of slag of a previous weld. I mean, you can. I mean, you could do anything, but that's not the way you do it. So make sure that you clean the previous one before you lay down the next. Either way, let's do it. All right, another decent pass. Let's clean this up and just keep going. Man, I got to tell you, this thing is coming out a lot better than what I anticipated. Let me bring you guys in and show you the results. Now, this may not come off crystal clear through the camera there, but there are 3 passes here. The original root that I showed you guys, and then my second pass was between the root and the angle iron, and my third pass was between the second pass and the side of the square tube here. So this is a traditional fillet weld. If you need to put multiple passes, this is generally how you would do it. But I tell you what, we just built up probably, oh, I don't know, 7/16 or ½ inch worth of weld with a 120 volt extension cord. Now, like I mentioned, this isn't show stopping, but if you need to melt iron together, this thing can do it. Look, we got 2 pieces of 1/4 inch steel and we put them together. Now, I tell you what, let's just beat on this thing and see what it takes to break it off. All right, so we got our freshly welded chunk here. I threw on some googles for safety, and just got a big old dead blow here. We're gonna put that welded side down, beat on this side to try to like cantilever it. You know, this is just a good way to test if it's gonna snap or not. So let's just beat on this thing. Tell you what, it broke, but it took a good bit too. Now keep in mind, I did not prep the base metal. So, you know, this could have been better, but either way, this is a good destructive test. Let's take a look at the weld and how it failed. Man, I tell you what, I think what happened here is not so much a failure of the weld, but a failure of my prep. You guys can see here, maybe, there is slag trapped in the root of my second pass. So I'm thinking maybe that I just didn't clean that up good enough, and then that was our point of failure. But either way, you guys saw me pounding on that thing. I mean, there wasn't no baby smacks there. I was hitting that thing. And for what we got out of 3 passes, 3 2-inch passes out of flux cord, that this thing just came out of a box and we plugged into an extension cord. I'm telling you, man, if you're just trying to like tack together the deck on your lawnmower, or, you know, like fix the wife's flower pot hanger or something, I'm telling you, man, I think this would really cut the cheese for those dumb little projects. Now, naturally, this is not a Miller, it's not a Lincoln, it's not an ESAB, it's not a Hobart, but keep your expectations in lane with the price, if that makes any sense. All right, if you buy a good machine, you're going to spend good money. Not saying that any money isn't good money, but this thing for the price point, and you can still scab together 1/4-inch iron with it with flux cord. And like I said, this thing has the capability to do solid wire. It has the capability to do TIG and GMAW. We just didn't do it for this test because this, I feel personally, that MIG is the easiest right out of the box thing to learn, because you just ground it, hit the trigger, and you're melting iron. So yes, it can do the other processes, and it's cool that you have the capability to do that, and it comes with most of the stuff in the box to do that. The only thing that you really don't have is the TIG setup, which, I mean, that's a whole other animal. If you're TIG welding, you didn't buy this to do that. Let's just be honest. And if you want to use solid wire, you need to get your own regulator set up for this, which, I mean, they're not difficult to get. You just need to know what you're getting and the different threads for the different tanks, and whether you want a flow meter or a regular dial regulator. Anyway, I feel like this is the point of this machine, is to run regular old dirty flux cord, doing stuff in a field, you know, in the basement, or just, you need to melt something together. You need to do it quick, and you need to have a limited power source. Like, just throw an extension cord through the window, hurry up, zap this thing together so we can get out of here. I feel like this hits that on the head. So guys, in conclusion, what do I think? I think that you guys pretty much know what I think here. Am I getting rid of my Miller in lieu of this? Absolutely not. But if you do stuff, or if you want to do stuff like this, I feel like this is a good way to dip your toe into the weld pool. Oh, I'm sorry. Dry dad jokes. It's a thing. It comes with the territory. So if you're looking for that quick little thing, maybe you just got a small project that you want to do, but you don't necessarily want to pay the big bucks to do it, or you don't want that hassle of taking it to a fab shop or whatever, you get the point here. If you got little stuff that you want to put together, this might be just the thing to get you out of that jam and do the project that you've been looking to do. Now, bear in mind, like I said, we did not do the 240 test, which I'm sure would greatly improve the output of this machine. And we didn't test the other processes with GMAW or TIG. And to be honest with you, I mean, that'll just make this video 6 hours long. And for a review of this cute little thing, I think that's just pushing it anyway. So keep in mind, it can do that stuff, but it doesn't necessarily come with all the stuff to do it. So we are just focusing on the down and dirty and what I think this machine is for. Can it do it? Yes. Is it the best at it? No. So keep that in mind when you're shopping for this thing. It is good for what it is. If you got dumb little stuff, tacking something together, you know, you need to put the fender on the car to get one more inspection sticker, this might just get you through. Or something dumb, you just throw it in the toolbox in the truck and keep it with you in case you need it. That might be a good application for this thing. So overall, is the BestArc MIG145 worth it? I give it a solid 60%. Yeah, it's not great, but it does what it needs to do. So hopefully you guys enjoyed this little review / tutorial thing here, and we'll see you next time.